Calc's right here. Calcium?
I'm not. I'm literally okay. Literally,
There's two, right?
Thank you, Mr.
Oh, it's this way. Okay.
Thank you.
Jesus.
Easy, right?
Bro, look at what you
Calcium.
did.
Uh-huh. I don't think you did this right.
Stop
You
looking.
did do it.
I love you, Mr. Beast. I love you, Mr. Beast. No.
Oh.
I love you, Mr. Beast.
Yeah.
Cool.
¿Qué estás haciendo?
Yeah.
What do you mean?
Yeah. Okay, well, 53. Okay. I was just making sure.
Bless you,
I thought
multiple
it wrote
times.
33 for some reason.
You're welcome.
Stop copying me. They just come in the right person.
Holy Jesus.
Ooh, what did I type? I'm typing goofy on a board.
Yeah.
Bless you again, kind of, maybe sort of.
Wait, what is this? I don't know what.
Oh, this needs to be converted into.
Yeah, yep. I knew that's what I was doing right now. What? Okay, okay, that right.
Nope, I don't know why.
Why? I don't understand. I can figure out.
So look what you have. You need to find the mole. Your mole is how you need
I think I'm feeling like.
No, I literally. That's what that is. It's leader.
I don't think I'm gonna be a reporter for something.
Jeez, dude, you do that much math and you need two calculators at the same time? That's
Oh, yeah.
amazing.
No, it's not.
No.
No, it's not. 0.35.
Yeah, it's 135. You get it? Did we do it?
And then CA.
Be a good idea to have your periodic table out, ladies and gentlemen. Be a good idea to have your solubility chart out. Be a good idea to have a calculator on your desk, because those are the things that you are going to need.
That's not pretty. That's the clouds. Clouds are more. I got it, Mr. Brand.
Do ya?
Yeah.
Awesome.
I'm just kidding. Wait, look at the pen. I want to see if I can yeah. I'm like, let me do a real. Okay, can do the time. I'm gonna do this.
We just order.
Irving, what are we trying to find? What? Molarity. If you don't know what you're trying to do, you're going to have a hard time doing it, ladies and gentlemen. I will tell you this, most of the problems that you do, either in the first few words of the sentence or the last few words, it'll tell you what you're looking for. What is find the molarity? All right, Eric, how do I find molarity?
Is it mole over volume?
So I need moles over volume. Volume in what unit, Eric?
Liters.
Liters. Okay? So that is what I have to do to find this. Now, I am not using a molarity. I'm finding one. We can use a molarity to get from liters into moles or from moles into liters, but you have to be given that. In this case, you are actually finding the molarity. That is what you are after, ladies and gentlemen. Okay? So with that in mind, start out with your 115 grams of calcium chloride. If you cannot write the formula for calcium chloride, ladies and gentlemen, you are going to struggle. CaCl2, calcium is a +2 charge, chlorine is a -1. We then take this times the formula mass. Formula mass for calcium chloride is 110.98. Now again, if your numbers and my numbers vary slightly, a few tenths, a few hundredths, that is okay because you may be working off of a different periodic table, something along those lines. And finally, we end up with 1.036 moles. I do not care about sig figs in this step. So that's why I'm leaving about 4 sig figs there. We then, to find the molarity, we take the moles divided by the volume. But your volume must be in what unit?
Liters.
Liters. So I have converted 135 milliliters into liters in my head by dividing by 1,000. You do not need to show me this calculation. You need to do it. You don't need to show it to me. When we divide these two, ladies and gentlemen, it ends up becoming molarity. Because by dividing these, it becomes the moles per liter, which is what molarity is. So when we divide this, our number becomes the molarity. Questions?
No, sir.
Yes, no, maybe so? All right. Please make sure your phones and headphones and things are put away, ladies and gentlemen, and let's get to work for today. So, in your EISN, ladies and gentlemen, we are dealing with mass-to-mass stoic relationships, meaning we are given the mass of something at the beginning and we are asked to find the mass of something in the end. Okay? Now, the first step in these problems is always to write a balanced equation. So, determine the mass of copper needed to react completely with a solution containing 12 grams of silver nitrate. So, the first thing that we need to do here, ladies and gentlemen, is begin with what are our reactants. So, we begin by writing down our reactants, ladies and gentlemen. So in this case, we have copper. Copper is just Cu. It is a metal. It is not with anything. Reacts completely with a solution of silver nitrate. Silver nitrate is AgNO3. If you're wondering how I got that, Ag is a +1, NO3 is a -1. Put them together, you get AgNO3, and because it's a solution, it is aqueous. Questions, ladies and gentlemen? Now, this is setting up to be a single replacement reaction, meaning the copper and the silver are going to change positions. So, that will give us copper nitrate. Now, copper is a +2, nitrate is an NO3 -1. And by the way, in this problem, I didn't tell you that copper was a +2. I would have to tell you that because there's no way you can know it by looking at the periodic table. So that ends up being Cu, NO3, parentheses 2. And that is aqueous because in a single replacement reaction, the compounds are always aqueous. The other thing that is created here, ladies and gentlemen, The other thing that is created is the silver metal, Ag. The next thing that we need to do with this is to balance it out, ladies and gentlemen. So copper, silver. I am going to do a little trick here. I'm going to leave the nitrate group together. Why? Because it appears as a group over here. It appears as a group over here. I could break it apart. If this trick bothers you, don't do it. Break it apart. But I know this. There is one copper over here. There is one silver over here. And there is one of these nitrate groups over here. How do I know there's only one? It's not in parentheses with the number outside of it. On this side, I still have one copper. I now have two nitrate groups. And I have one silver. So to balance off the nitrate, ladies and gentlemen, I'm going to double it. So I'm going to put a 2 in front over here in front of the AgNO3. That does give me 2 nitrates, but it also gives me 2 silvers. So then I have to come over here and put a 2 in front over here. Now I have everything balanced. Does anyone have any questions on the balancing part? Any questions on the writing the formula part? Okay. I need this because it is the only way, ladies and gentlemen, that I can get the ratios I need to compare one thing in this compound to another. Now, I am also given 12.0 grams of this solution. Okay? The solution has 12.0 grams of this in it. The question is, how much of this do I need? And I need it in grams. Why? Read the question and tell me why. Doesn't matter. Read the first 5 words of the question. Determine the mass of copper. What do we measure mass in? Grams. So we're going to have to get it into grams. Okay? Now, to do this problem, ladies and gentlemen, I am going to begin with 12.0 grams of AgNO3. What is the first thing I need to do to this, ladies and gentlemen? I need to get it into moles. AgNO3. Silver, 107.87. Yes? Okay, thank you. Nitrogen, 14.01. 3 oxygens at 16 is 48.0. If you're wondering where those numbers came from, that is the mass of each one of these times how many of them there are. So we end up with 0.88. This gives us 169.08. Where does that go here?
On the bottom.
On the bottom. Only way to get grams to cancel. Now, I will tell you, it is important. Oh, sorry. There you go. Thank you. Okay. Now, I will tell you, ladies and gentlemen, you need to keep track of what substance you are talking about. Because in these problems, we are going to go from one substance to another. You have to keep track of what substance you are talking about in these. That is why I'm labeling it grams of AgNO3. That's why I labeled it moles of AgNO3. So that I can see that. Because my next step is to use what is called a molar ratio. A molar ratio allows you to compare 2 parts of this equation. I don't care what 2 parts you want to compare. You could compare this reactant to this product, this reactant to this product. You could compare these 2 reactants. That's what it asks you to do here. So we use what we call the molar ratio. Now, even though there is no number in front here, what is the molar ratio for copper in this?
1.
1. There is nothing here, but that would mean one of them. Now, I'm in moles of AgNO3. I'm going to create a molar ratio here from my balanced equation. That means I am going to go from one part of the equation to another. And I do it by using the molar ratios given in the balanced equation. So, where do I need AgNO3 to be to cancel? I need it on the bottom. Now, what is the big coefficient in front of AgNO3? So that means that 2 moles of AgNO3 go on the bottom here. I'm going to clean up some of this stuff on the side so I have some more room, because we've shown you why we did that now. On the top is going to be which of the substances I'm trying to get to. I am trying to get to copper. What is the number out in front? What is the coefficient in front of it?
1.
So that means I put 1 mole out in front, or 1 mole on the top. This will get me out of moles of silver nitrate. I'm already out of grams. That canceled already. And now I'm in moles of copper. If we wanted moles, we would stop here. But what did it ask us to tell us about the copper? The mass. So how do I get from moles to mass? We're going to use formula mass. And Morgan, you are absolutely correct. We are going to put grams on the top. 63.55 grams of copper over 1 mole of copper. Okay? So I got that right off of our periodic table, ladies and gentlemen. Now you are going to do your math. And again, how you put this into your calculator is going to determine what you get out of it. This number, even though there is nothing underneath it, is considered to be on top. So we take 12.0 times 63.55. Now the way I like to do it in my calculator is then I hit divided by. I put a parenthesis in. And I do 169.88 times 2. And then I close my parentheses. If you do it exactly that way, you will get the correct answer. Eric, what did you get?
I got 2.245.
Did you get the same thing? Good. Then we're cooking with gas today. So the number again is what again, Eric?
2.245.
What's the unit?
Correct. Copper.
Now, one last thing. Okay, how many?
3.
So in 3 sig figs, this number becomes what?
2.24.
2.25.
Wait, 2.2.
Well, this 5 says move this 4 up.
Oh, yeah.
Okay? Now again, ladies and gentlemen, I will let minor differences in an answer go, because depending on if you do this all at once or if you do this in steps, okay, you may come up with a slightly different answer because of rounding. I will let those go, but you better be near 2.24, 2.25. Questions? Yes, no, maybe so. Okay. So, I believe this problem is done for you in your notes, correct? Okay, good. So you don't have to worry about copying this down, writing this out. You have to worry about following along. Okay? So again, ladies and gentlemen, first thing we would do is write a balanced chemical equation. Now, if you need to, go back and look at the Unit 3 EISN for writing formulas and compounds. Okay? Silver phosphate Let me start again. Sorry, my bad. I'm looking at it and I'm thinking I messed up the problem right away. Calculate the mass of silver phosphate produced if 30.0 grams of silver acetate reacts with excess sodium phosphate. So, silver acetate. Silver a +1, acetate a -1. Therefore, you get AgC2H3O2. Questions on that? Sodium phosphate. Sodium is a +1. Phosphate is a -3. When we crisscross, we get Na3PO4. These are both aqueous. What kind of reaction is this setting up to be? Come on. There's only 4. Synthesis, decomposition, single and double replacement.
Double.
This is setting up to be a double replacement. Okay? Now, silver phosphate is one of our products. It says that originally in the problem. So here is silver phosphate, Ag3PO4. Again, silver +1, phosphate a -3. That's why we get this formula. And if it's asking you to find the mass, that's going to be your precipitate. That's going to be your precipitate. That's going to be the solid that settles out of solution. Since silver is switching places with sodium and silver is now with the phosphate, sodium goes with the acetate, NaC2H3O2. +1, -1. No need to put anything down below. Questions? We put a 3 in front because there are 3 silvers here. There are now 3 silvers here. Okay? C2H3O2, there are 3 of them. What's wrong over here, ladies and gentlemen? I need a 3 in over there. I need a 3 in over there, ladies and gentlemen. So, I need to do a little editing here. You may have to put this in there because I don't think I did for you either. Sorry about that. Let's get back to it. Now that we have it balanced. Now again, ladies and gentlemen, not going through this with you every time, but I would set up my scoreboard, silver, sodium. I would do, you have a choice. One of the tricks we learned is when you have oxygen in everything, you can ignore it. So you could easily ignore oxygen here. Or because PO4 appears the same on both sides, I could list it down here. The same with C2H3O2, because it appears the same on both sides, I could list it down here. Question, Josie?
Just like group it together.
Just like group it together. I would only do that because they don't change on either side. They're here and here, it's the same. So then I count up the groups. 3 groups over here now, 3 groups over here now. 3 sodium, 3 sodium. 3 silver, 3 silver. 1 PO4 group, 1 PO4 group. I have everything balanced. Questions? I will be more than happy to help go through balancing with you if you need to. But I'm not going to do this in class because there's some people who probably have it and some don't, and I'm not going to waste those time who understand how to do it. Questions? Now, this is a minor step, but it is a step that I take the time to do on these problems. Identify what you are given. I am given 30 grams of this stuff. So this is where I'm going to begin the problem in just a minute. I'm given 30 grams of this stuff. I am looking for how many grams of this stuff that I am creating. What this does is this tells me to focus on going from here to here at some point. And I'm going to need a molar ratio to do that. But the problem begins with what I'm given. 30 grams of silver acetate. What do we do to it? Get it into moles using formula mass. The formula mass of silver acetate is 166.92. Silver, again, 107.87. Carbon, 2 of them at 12.01. 3 hydrogens at 1.01, 2 oxygens at 16. Add that all together, you should come up, if I did my math correctly, of 166.92. What is the next step? Molar ratio. So we've taken what we were given, got it into moles. Next step is the molar ratio. The molar ratio between what I want to find and what I am given. And in this case, what is the ratio for what I want to find to what I was given? 1 to 3. 1 mole of silver phosphate over 3 moles of silver acetate. Again, coming right here from the coefficients that are in front. I am now into moles of silver phosphate. But again, what ultimate unit do I want? Not moles, but grams. So how do I get back to grams? Formula mass. So that unit 5 stuff. Grams to moles, moles to grams. Here's where we're using it all the time. So this is a lot higher. Why? There are 3 silvers in here. 107.87. There is a phosphorus in here at what? 30.97. And there are 4 oxygens at 16 each. That's 64. So this is a lot higher number. Now you're in the unit you want to be in. You're in grams, correct? So all we got to do is the math now. We take 30 times 418.58 divided by, and again, I would use parenthesis, 166.92 times 3, close the parenthesis, you should come up with around 25.0766. Questions? Now, the only thing wrong with that is what?
Sig figs.
How many sig figs?
3.
And again, sig figs are easy, ladies and gentlemen. Go back into your problem. How many sig figs in this number? 3. How many in your answer? Should be 3. Questions? Okay, ladies and gentlemen, we got about 30 minutes on the clock. You've got your worksheet packet. Go to work. If you have questions, call me over. I will be happy to help you, ladies and gentlemen. You want to go back and work at a lab station so there's more room for you? Please feel free.
Yeah, that's coffee though. Right there.
I can go back and I can see. Give me just a second, okay?
Dude, I swear my packet grows legs and runs sometimes.
After number 1, skip to page 2 and do 4, 5, 6. I'll show you how to do 2 and 3 in a minute, ladies and gentlemen. You might be able to do them, but I just haven't shown
Oh, okay.
You might do this one.
You can't get rid of it. Oh, you know, I don't think that.
That's what. That's
And we require that it's produced, it has to be after that.
oh, wait, wait. surprising things that you haven't made some flat. I'm surprised. I'm so used to working with I'm not going to eat that. About 20 minutes left, ladies and gentlemen. These are still no, there's two. So here is what happens. Oh, yeah, there's. Because I know they both like
I don't know.
always.
His head isn't that big. He doesn't have a galaxy brain. He thinks he does, but he doesn't. Josie, I got that. I got the answer that I was supposed to, but I had the wrong mass in it. So let's double check here. And that is not unusual for me to do something like this, Josie. What I mean by that is, um, I copied and pasted the thing, but I must have used the correct number. I didn't copy and paste that one. Okay, stop. I don't want to show you that, but in reality, so again, about 8 minutes left, ladies and gentlemen. It's going to be a complicated not double always. This is always going to be home. This ratio is not here, or the numbers
Oh, this is not doing. Okay. What she's saying is you should get the word mold as well. Because then when you put mold down there, those things will cancel. I was on what? Which one goes on top? Okay, well, here's the thing. You always start out by getting it into molds. That's what you're doing. Then we use the mold ratio. Compare one unit ratio to another. Okay? So in this case, an HCl to the HCl that we created. Then we're going to do one more step, getting it out into its proper unit, which is grams. So as Manny was just telling you, we do the formula mass now over 1 mole of HCl. So these problems, take the first step here. Take what you're going to get it into mold. You use the ratio, compare where you're at to where you're going to. And then the last step is to get it out into the proper unit, which means since they want grams and not moles, we're again using formula mass, but it's a different formula mass because it's a different substance. Okay? So here, we were getting out of grams of silver acetate into moles. Then we use a molar ratio. After the ratio, we're now in moles of silver phosphate. Okay? So this mass is different from this one because this substance is different. But this is unit 5 going from grams to mole. This is unit 5 going from mole back to the grams. Okay? Come in, Josie. Molar ratio? Yeah. Okay. Different moles of what? So then on the one. Whatever compound is already put up, it goes in. Okay? That's why we balance the equation. It gives us that ratio.
Oh, well, yeah, that's
So, Don't even beginning of those things down. Formulas for those, put an arrow, and then products.
All right, ladies and gentlemen, come on back to your seats, please. All right. Now, well, this is probably the simplest kind of problem you are going to get. This also shows everything that you need to do. Now, what I mean by that is the steps that are in this problem right here are the steps that you will do in every single problem. You will just have to do it in different ways. Let me explain. This part right here, this first part right here, is taking what you're given and getting it into moles. You have to do that. Now, how am I going to give you information? I'm going to give you grams. You're going to use formula mass. I may give you the volume of a gas. Now we need to use PV equals nRT. I may give you the molarity of a substance and the liters of it. That's what we just worked on yesterday. Taking molarity and volume and getting it into moles. So no matter what you do at the start, you've got to take what you're given and get it into moles. That's what we're doing here. Step 2 is to use a molar ratio. Now, the only way you can get a molar ratio is to write a balanced chemical equation. The only way you can write a balanced chemical equation is if every one of your compounds is written correctly. I've seen it for years. People call me over and go, Mr. Brand, I cannot get this to balance. And I look and I say, okay, double check this formula. Because if you mess up one formula, you will not get your equation to balance. If I do not put Ag3PO4 here, if I leave out this 3, or I make it a 2, this will never balance. So if you're getting to the point where you're getting frustrated and you're like, oh my God, I can't get this to balance, take a breath, look at each compound, make sure they are written correctly. Okay? Now again, it's been a long time since we've done this. But you gotta go back, look at how to write formulas. If you have questions, you gotta ask. Because you can't do any of this if you can't get this. Now when you balance it, you're going to put a ratio in here. Now this ratio takes care of the fact that there are 3 of these to every 1 of these. But you could well look at any 2 parts. How do I know which parts? Well, it told me I was given this and it told me I'm going to this. So because of that, ladies and gentlemen, what I'm going to is always going to be on the top here. Always going to be on the top here. And the one I'm in is going to be on the bottom. Now, Pierce, I'm going to use him as an example. He was doing his problem, and he wasn't doing it incorrectly, but he was accounting for this ratio twice. Because what he then did is over here, he had one where there was a 3 in front or a 2 in front. So he doubled his formula mass. Because he thought, well, a 2 in front, that would make it double the mass. Don't do that. This step here takes care of the ratio. Then our final step, just use formula mass again. What the formula mass is equal to 1 mole. This accounts for the fact that there are 3 of these compared to 1. You don't have to worry about it anywhere else. Anywhere else. But, summary, write a balanced equation. Take what you're given, get it into moles. Use the ratio to compare two parts of the reaction. Finish your question out in the unit that they wanted. That's what you're doing in all of these problems. All of them. Questions? Go.
How do you figure out if it's no reaction right now when they're all aqueous?
If they're all aqueous, there would be no reaction. Only if it's a double replacement reaction, though. Double replacement reaction, no precipitate, no reaction, boom, you're done. Move on. Now, if you want to practice still doing the problem, you can, but that's what you'd write, no reaction. Question. All right.
What's going to be on our quiz tomorrow?
None of this is on your quiz tomorrow. The only thing on your quiz tomorrow is 3 questions on molarity. You're going to have to calculate a molarity. You're going to have to use a molarity to go from moles to liters. You're going to have to use a molarity to go from liters to moles, just like you did yesterday. That's it. That's the only thing on the quiz tomorrow. 3 questions. Other questions you have? Okay. Now, please close your computers. Okay? And just watch. Okay? Just watch. Different question now. In the formation of acid rain, sulfur dioxide reacts with oxygen and water in the air to form sulfuric acid. Write a balanced chemical equation for the reaction. Okay. Now, I have given you every reactant and every product in this reaction because this is not single replacement and this is not double replacement. This is a synthesis reaction. So, sulfur dioxide reacts with oxygen and water. Sulfur dioxide, oxygen. Why is there a 2 here?
That's too much dioxide.
No, it doesn't say it reacts with dioxide. It says it reacts with oxygen. Why is there a 2 by the oxygen? It is one of the 7 diatomic molecules, which will mess up your equation if you don't call it a diatomic. So sulfur dioxide, SO2. Oxygen, O2 because it's a diatomic. Water, H2O. Boy, don't ever make me give you that formula. Okay? Produces sulfuric acid. Not hydrosulfuric, that would be a binary acid. Sulfuric acid comes from sulfate. Ic acids come from 8 polyatomics. Sulfate is SO4. It has a -2 charge, so there have to be 2 hydrogens here. Questions on how I got any of this? Has to be aqueous. Now, again, we're not worried about does this reaction happen because this is not single replacement. This is not double replacement. This reaction actually occurs. I had to go through and I had to balance it. Balancing it is a bit of a beast. I've got oxygen all over the place. I've got sulfur. I've got hydrogens. Now this one, you know, I said you can ignore oxygen if it's everywhere. This one we couldn't. Why? Because it's the only thing here. So in the end, I had to balance it. But 4 hydrogens, 4 hydrogens. 2 sulfurs, 2 sulfurs. 8. What the heck?
My brain hurts.
4. Having a bad day when I did this one, ladies and gentlemen.
Does acid rain actually exist?
Yes, this is how it actually forms. This is what actually happens. Okay? All right. Sorry about that. There we go. I got a balance now. My bad. Okay. Identify what you're given. I am given 285 milliliters at 98.5 and 18.7. Why am I given all of this information? What? Well, what is this? A gas, right? So, for me to find moles of a gas, what do I need? Volume, pressure, and temperature. Volume, pressure, temperature. I'm also going to need a what value? I'm going to need an R value because I'm going to have to put this into PV equals nRT. Okay? Why? Because I got to take what I'm given and get it into moles. Ultimately, I want to find the grams of this. Okay? The grams of this. So I'm going to use PV equals nRT. So I would somewhere on your periodic table make sure you got your R values written. 98.5, I have to convert milliliters into liters. 8.31 is the R value. 291.7 converts the temperature into Kelvin. I get my moles. Now, I've got moles. What do I do with moles after I have them? What's the next step after we've taken what we've given and got it into moles? What? Nope. Before that. After we take what we've given and gotten it into moles, what is our next step in the middle? Nope. Nope. Doesn't ask for molarity. I am going to need to do the formula mass. I am going to need to go back to grams, but you're forgetting one step in the middle. Molar ratio. I need to use the molar ratio to get out of SO2 and into H2SO4. Yes, I know this is a 2-to-2 ratio, but you still need to show it to me. Now I will be in moles of H2SO4, correct? Now I want to go into grams, formula mass, ladies and gentlemen. We'll finish up tomorrow here. Have a great day. Goodbye. Go away. We'll see you later. Please make sure my calculators get back. And Jasmine, the one you were doing, you didn't have to do PV equals nRT because the gas was at STP. So
Yeah.
using 22.4 like you did was fine.
I did have one question. I
Okay.
think it was for number 3.
Okay. Well, why don't we look at it tomorrow?
Okay.
Okay?
Yeah.
Only because even if I tell you now, you're probably not going to remember anyway.
It was just something about the mole because it like for the what was it called? Something you just said right now. Because it said for 1 mole of something, but there was a 2 in front of the.
Okay. We'll look at it tomorrow.
Okay.
'Cause to be honest, I don't want to lead you down the wrong path right away.
Okay. Thank you.
Yes, sir.
Can I come in after school or before school? I just need help with converting liters to a milliliter.
You can come in after school today for a little while because I have parent-teacher conferences. They start at 3:30. So you got to get here right away. And yeah, because tomorrow morning I'm not going to be around. But yes, definitely. Come in right after school.
All right, thank you.
You're welcome. Grab a scrap sheet of paper, ladies and gentlemen, from the front part of the desk.
John,